Hello everyone, this is part 2 of the high-powered signal generator from the United States Air Force. If you've not seen part 1, please have a look at part 1 first, where we looked at the internals of the unit and obviously took it apart and did a strip down, a tear down of it. This is part 2, where we've got it connected up to a variac. Just wind it up slowly, a voltmeter there on AC volts, and we've got it connected as well to the HP test set, the RF output that is. Obviously, if you remember, just to recap, this is a very high powered signal generator or source. It does 10 watts and 80 watts, so we'll set it onto the 10 watt setting on the medium power range. I got it set at 200 megahertz. I presume when we've switched it on that we'll put it into CW mode, and I'm expecting to see this ready light come on. I think it has to warm up, obviously, because it's a valve, grid and cathode, etc. I think the heater has to come up to a certain temperature before it'll start to work. So we'll take it carefully. We'll not rush into it, because obviously it could go fizz bang and release the magic smoke, you know, so we'll be careful with it. So we'll switch it to on standby. We've got the AC voltage red here, and now we'll just begin to turn this up. And it works on 110 volts AC, don't forget. So we'll see what happens. There's no smoke yet. There's very little current being drawn, if any, what I can see on the other meter. Oh, I can hear the fan starting up now in the unit inside the signal generator. Seems to be okay. Still no significant current drain, and just get it up to 110 volts. Seems to be okay. If it were going to explode, I would have expected it to have gone by now. Right, I can't see a mains light on there yet, so I don't know if that neon's packed in. It's possible. We've got it set to 200 megahertz frequency on the frequency readout there. Just to recap, it goes from 190 to 600 megahertz. Just wait for the ready light to come on when the heater's got up to temperature, and see what happens. And then what we'll do, we'll switch it to CW mode there to get it to send a carrier out, and we will then adjust the power output and tuning here, I think. Oh yeah, look, we've got a ready light on. That's fantastic. I think it's ready to go. It's in low power mode at 10 watts at the moment, and we've got a grid and a cathode supply switch. Look of it. There's nothing registering on that as yet. So I'll just come back out. Right, so what we'll do now, we will switch this to CW. Oh, test set's already registering power, some degree on it. Look of it. Looks like we've got about a watt at 200 megahertz. Oh, it's on and off at the moment. This also is a power meter, RF meter, and it shows us power on the top scale for the 10 watts setting and the bottom scale for the 80 watt setting. So what we'll do, we'll just adjust this. So, oh yeah, we're getting something now. That's coming up. That's a couple of watts. Oh, it's gone there. Right. We're getting 6 watts out on the test set there already, and it's peaking there, I'd say. And then cathode volts on there. Let's have a look at the cathode. And then, grid the grid seems to just move slightly, whereas the RF power's on the left. So it's working, it's giving an output. We'll go to the next one. Oh my, doing 24 watts already, look. Let's have a look. Needles have gone off the end, so I wonder if I have to, oh, not like that. Got something to do with this coupling. There we are, look. And 23, 26 watts or thereabouts at the moment on the test set. 24 watts, and that's actually on the 10 watt setting. That's still on the 10 watt. I didn't flick it to high just in case, so I'll reduce its power down. I'll put that to the 80 watt setting now then. And let's see, we've got 3.7 watts coming out. Just adjust that. It seems to peak about there, I'd say. Right, we'll go to the next power setting. Have a look. Can't seem to get much power out of it there. Hang on, that's 20 watts because we're on the bottom scale. It says it's doing 24 watts. Just carefully tune it. And that's a fine adjust. So what does it do on high power then? Ooh, my word. My. Giving some stick out now. Blimey. 50 watts. Getting 50 watts out. Let's have a look if it's... Yeah. Getting 50 watts out. Let's see what... 49 watts. Seems to do quite a bit of power. I'll say that, I'll put it back to CW. And it's on high. That's to full. Right. 40 watts there. Don't seem to be able to get any more than about 40 watts. Oh no, we've got 52 watts coming out at that frequency. So it does seem to be working. Just turn the volume down on that because I think the test set's trying to lock to it. So that's good news. It's functioning. We're getting 52 watts output there, and it seems to be producing in combination with. It says it's doing 40 watts there, but I suppose the next thing to do is perhaps adjust that cowl pot there. So the grid says the grid is that's milliamp reading or whatever, and then the cathode. So don't seem to be able to tune it for any more RF power. The ready light comes and goes as well, I've noticed. There we go. Seems to like trip out. But with 52 watts anyway, so you know it's not exactly doing a low output level. Now that test set can only take 60 watts maximum, so I'm not going to increase the output power any more than I already have on that test set at least. But it proves it works, you know. I mean, it's chugging out 50 watts, so that's a good result. So it just shows you it's working. And see what happens when we tune to different frequencies, maybe. Wonder if it'll do more power at different frequencies. It seems to be, yeah, it's doing 55 watts now at 212 megahertz, so it seems to be going up. So I'm just winding it up, see whether we can get even more power out of it. And that's 230 odd megahertz, yeah. So the frequency is correct, 240 megahertz now. So it might need retuning now. Let's have a look. Yeah. It seems to be like internally tripping when you turn the tuning. What happens is it's tripping, so I think it's there we are, that's the RF power there. You're like a relay going inside. Yeah, it's very interesting. Getting some output power out of it. So yeah, nearly 60 watts there, look. Steady. 58 watts at 242 megahertz. So I'm wondering if it'll go even higher, but just got to be careful of the test set. I don't want to blow up the HP Agilent. I've got another high-powered meter. That's 300 megahertz. Let's see whether we can get some more coupling out of that. Yeah, we're not far off though. We're getting up to that 62 watts there, look. So I'll just switch it off. That's it. So I don't want to damage the Agilent test set. That's can only take 60 watts output power. So yeah, it looks like it's all functioning and working. Just shows you after all these years. Produces, you know, 60 watts at 300 megahertz in that case. So it'll be interesting to see if it produce 60 watts at the 430, 440 megahertz band. Let's have a look at 4, about there I think. We'll switch it back on and we'll adjust the tuning on here. Let's see what happens. Oh yeah, power's coming up. Yeah, it seems to go to a maximum there of about 40 odd watts. So at that frequency. So it seems like in the VHF band it does more power than does more RF power than it does in UHF. But still, I mean, it's, you know, it's producing some significant power really. Obviously I've not adjusted these cowl pots yet, so I think it'll be worthy of more experimentation. But yeah, it's very interesting. Of course we've got, you know, cathode and grid volts. It's doing 44 watts at the moment, 45 watts. I just can't seem to get any more juice out of it at that frequency. 47 watts maximum I can get there, and obviously let's get it up to about 600 megahertz and see what the output power it does. According to the test set, it's not doing anything yet. Let's just try and tune this, see if we can get some tuning out of it. It's trying to do something. It's not quite making it though. It's doing about 4 watts at 600 megahertz, nearly at 555 megahertz, 553 megs. That's as much as it seems to do there. So it's like right on its limit. So if we just turn that off and then adjust that down to, I think it was 190 megahertz, where it was its lowest frequency, or thereabouts, and then see how much power we can get out of it at 190 megahertz. and seems to be warm in the room. You can feel the heat coming off the valve, and it's warming the room up. It's like having the central heating on with this thing going. Let's have a look here. It's quite warm. I can feel the hot air blowing out the top. Relatively warm air anyway, so let's go back to CW. Alright, like it's tripping. Oh, hang on. Oh, no. I'll just back off the power because the variac were getting a bit stressed out. Let's have a look here. Just adjust it for that power there. Maximum RS about there. Doing 21 watts, 192 megahertz. So we'll just need to fiddle and twiddle with it. So we'll just go and back this off a bit, go to the high power setting, and then what we'll do, we'll tune this for maximum output, which is about there. It's doing 21 watts, and then it's going up to 30 watts, 40, 49, 50 watts. It's doing 50 watts there, and I'll just adjust this tuning thing to see if we can get any more stick out of it. But now, I wonder if the yeah, you see the supply is going down to 37 volts. So the more, hang on. My mistake, 110 volts, it's still there. I'll just wind it up to 120 then, because I know it can work at that. 117, we'll leave it at that just for the time being. I'll just adjust this. The area, the variac humming, and the ready lights coming and going. Yeah, so it seems to peak, I'd say, around about 51 watts at 190 megahertz. So I think the most power we get out of it is about 250 megahertz, I think. So just adjust that back for about 250 megahertz, I think it was. 220, 230 coming up, 40 and 250. Right, let's have a look, see how much juice we can get out of it now. Right, certainly peaked it. Let's just have a look at the coupling. Just adjust that. $57 seems to peak at about 57 watts. 61 watts. Certainly don't want to drive it any more than that, so I'll switch it off. So as we can see, it's all fully functional. Quite pleased with that. I'll maybe get some use out of that at some stage. It's a very nice little unit. I'm glad to see it's working after all this time. It's probably not been switched on in years, and it seems to be working quite well. So thank you for watching the video. If you found it interesting, this old piece of kit, that it still functions after all these years, and obviously refer to part 1, the video that I did earlier, if you're interested in what it looks like inside, and a little description of some of the circuits. And thank you for watching the video. I'll see you in the next one. Thank you, bye bye.